Good morning, dear student. I am Monica Khirajani, Assistant Professor at SIT Bhopal. The subject is compiler design, and today's topic is introduction of compiler design. So let's start with the introductory class of compiler design. Now, what is a compiler? Compiler is a software, or you can say that it is a translator that translates the program written in the higher level language to the low level language. As we know that the computer understand only the low level language. So for compiling the any program, so you need to translator which translate the program written in a high level into the low level language. The main purpose of compiler is to change the code written in the one language without changing the meaning of the program. This is the main purpose. Now, there are the three types of compiler used to translate the high-level language into the target code machine. The first is a single-pass compiler, two-pass compiler, and multi-pass compiler. Now, what is exactly the pass? Pass basically refers to the traversal of compiler through the entire program. Uh, uh, how many times it is required the compiler to traverse throughout the entire program to translate the high level language into the low level language. Now, what is single pass or a one pass compiler? As you know, when we compile the program, it passes through the different phases. As you see in the program, these are the different phases through which our compiler uh, translate the whole program into the low level language or the machine code. Okay. So when we use the single pass compiler means compiler is used to traverse the program only once. One pass compiler passes only the ones through the parts of each compilation unit. These are the different units and it passes only the ones through it translates each part into the final machine code. In a one pass compiler, we can also say that when the line source is processed, it is scanned and token is exerted. Then the syntax of each line is analyzed and tree structure is built. After the semantic part, code is generated. Same process is repeated for each line of code until the entire program is compiled. Okay, so as you also see the second image of this single pass compiler, it basically means that it is used to traverse the program only once. Now the two pass compiler is basically, as the name suggests, two pass compiler means program need to translate it twice to convert the high-level language into the target code. That's why its name suggests the two-pass compiler. As you show as it is shown in the diagram, that first we have compiled the program in the front end, then again we will convert the front end program into the back end to get the target code program. Now, these are the operations which are performed by the compiler. First, it breaks down the source program into the different chunks and applies a grammatical structure to each one. And it enables you to create a symbol table and target program you are after from the intermediate presentation. It also helps in compiling the source code and detecting the errors. When we perform any errors, it's a responsibility of compiler to show the errors and organize and save the all codes and variables in the symbol table. It separates out the compilations. Separate out compilation is supported by the compiler. It reads the whole program analysis and translate into the semantically similar language depending on the types of machine, converting the source code to the object. So these are the important tasks executed by the compiler. Now the cousins of the program, these are the different programs which also help and assist the compiler to translate the high level language into the target language or the machine or low level language. As we know that when we write the program, we also include the hash characters, micro expansion like hash define in the at the starting of the program we define the all director including files and hash define. So it's a responsibility of preprocessor to remove all these in hash include directors or hash defined directors. It basically modified the only the useful code is passes to the compiler. Then compile, as we know that it compiles the whole program and translate into the assembly language. Then then the program is passes to the assembler for every platform hardware and operating system. We will have the assembler and they are not universal since for every or each platform we have the one. The output of the assembler is called the object file. It translates the assembly language to the machine code. Okay. So object file actually as we know that there are three files are used and that is the header file which having the extension .h and one more file is the OPG files. OPG file basically contain the machine-like instruction, but it is not the executable file. So it's a responsibility of linker which links the all parts of the program together for the execution for creating the exe file. Because without exe file, we are not able to run the program. Now next is a relocatable machine code. It can be loaded at any point and can be run. The address within the program will be in such way that it will cooperate with the program movement. Linker to as already we discussed, as we know that when the compiler compiles a program, it divides the whole program into the chunks in a different chunks. So linker tool is responsible for links the all different parts of the program together for creating the exe file or executable machine code. Then loader loads the all of them into the memory. Then our program is executed. Now, these are the different phases through which high-level language is converted into the assembly code with the help of the compiler. So, these are the different phases. First phase is a lexical analyzer. Uh, as the name says, lexical means it's scanning the whole program and converted into the streams of tokens. Then output of the stream tokens is used as an input for the syntactical error to find the exact syntax of the program. Now the output of the syntax tree is a parse tree, which helps to find the syntax of the program whether it is correct or not. Semantic analyzer uh, which used parse tree as an input and convert into the annotated parse tree to verify whether the parse tree is corrected uh, or any variable which is defined is having the scope or not, is within the body or it is used out of the body. So all these behavior is checked by the semantic analyzer. Then output of the semantic analyzer is the annotated parse-tree, which is used as an intermediate code to generate the machine-like instructions. And till that, all these, uh, suppose I want to design the one more compiler. So from starting lexical to intermediate code for the all compiler will be same, only the difference in their code optimizer and the target code generation will be the different. So the next phase is the code optimizer, which is, as the name suggests, it optimize the code to means for reducing the time complexity and space complexity. And then we use the target code generator to generate the target code. And there is a one more special data structure is access or used by the all phases of the compiler, that is a symbol table which is hold or stores the all variables and the parameters in the symbol table and accessible by the all phases. And if any phases is facing the any problem or errors, it is handled by the error handler. So in the next class, we will discuss or we will learn or with all phases in a detail with an example. Thank you so much. Stay tuned and keep learning.